All right, here's another problem. Let's find the derivative of f of x. Graph f prime of x, or the derivative. Okay, so here's f of x in green, and the derivative means the rate of change at any given point. All right, well, if you can see that this is f of x, you can see is just the x squared function, right? But it's moved a little bit. It's moved right 5 and up 2. So it's really, you can actually find the equation for this. It's really x minus 5 squared plus 2. That's what the green graph is. I should write that in green, I guess. F of x equals x minus 5 squared plus 2. Okay? So it's shifted over. Well, they don't want you to actually write this equation out, but I'm just showing you as an example. This squared here, anytime you have a derivative, it reduces the degree by 1. So what would the graph of the derivative have to look like if it reduced the degree by 1? What's 1 less than a quadratic? A linear, that's right. So f prime is going to be some line. It's going to be some line mx plus b, right? And so here's how you find that. Well, this point is the key right there. That point, the derivative is 0 because it bottomed out right there. So at that point, I go straight down. I go straight to the x-axis, and I know that point's going to be on my line. That point right there is going to be on the line, and from here, all of these points on the left have a what? Are they changing positively or negatively? Is the rate of change positive or negative? Yeah, it's negative. So all those values are going to be below the x-axis, and all of these values to the right are going to be, see how the rate of change is positive? Those are all going to be like that. So your derivative graph is going to be, that's the key right there, is find all your bottom out points, all the points where it bottoms out, and those have to be x-intercepts. X-intercepts of the derivative are x-coordinates of max or min points in these, at least in these very basic ones, in polynomial graphs, which we have right here. Okay, so if you had another polynomial graph, let's say you had one like this, what kind of graph is that? If that's your f of x, what kind of graph is it? I didn't draw it very good, but if there's two peak valleys and it's going down on the left, up on the right,
cubic.
It's going to be a cubic. It's going to be some sort of a cubic graph. And what's the derivative got to be?
Wouldn't it be a quadratic?
The derivative has to be some kind of quadratic, right? There's something in front of here, but it's just some kind of quadratic, right?
Yeah.
And guess what these points have to do with?
Those are your bottom out points.
Exactly.
So those are your x-axis.
Those are your bottom out points, right there and right there. And you can see that right here, from here to here, is it increasing or decreasing?
Increasing.
No, going from left to right. Is it increasing or decreasing?
Increasing.
It's increasing from there to there, and it's also increasing from here to here, right? And it's decreasing in the middle. What does that mean? It means that the slopes are negative when it's decreasing for the derivative graph, and the slopes are positive when it's increasing, which means this graph has to be going above the x-axis to the right and to the left of those points, and below in between. So that's what your graph, roughly, that's what your graph's going to look like. Okay, so the important thing is that these points line up with those points, and that the shape of the graph, increasing and decreasing, relates to above the x-axis or below the x-axis for the derivative.